building our boat that's actually going to power itself. First, we need to build the part that is going to move it. Let's take the rubber band, because we know that that's where the energy is going to come from. Take our paddle. Now, I'm not going to be able to use my fingers. I want to use some tape. So I'm going to start, and I'm going to tape another piece, and I'm going to tape this side down. Type of structure where if I put something inside of here, I can twist it around and I can let it go and it stays. So that's good. So we have to go inside of here. So maybe if we use them both to see which one works better. Let's put this up like this. It's not the easiest. Look, the straw bent. Which material do you think would be better to use? I think the wooden skewer. This is all part of about right now is that do we want to put it lower on the cup or do we want to put it higher on the cup? Let's kind of start lower and see what happens. And then if we need to redesign, we can redesign because we don't really have a lot of background. Let's stick this one here. Now, the one thing I do want to make sure is that the cup or our skewers are at the same angle. So that way I want to make sure my other one also is at the same angle. Here, got my other piece of tape. So I'm going to tape that down. Okay, so now we have our boat and we have our ending here where we can attach our paddle to. So if I just attach this here, okay, and then I would line it up. Okay, so maybe we should try it out and see what happens. Okay. And when I pull it out, I can see why. We attached that, or we went too close, so it's stuck on that. Actually start unwinding. And I'm noticing something else. Look at how flimsy that is. That's not gonna work, is it? What could we do differently so this was not so flimsy? We only have cardboard like this, and every time we put it in the water, it absorbs the water and bends. Oh, look, so I took this off. It's dry. So what if we covered a whole cardboard piece? Well, it happens to be that I've done that. So let's try it out, but this time just with this duct tape piece. There is one thing that I did on here that I think is gonna not be so good for us. And I didn't cover these two endings with duct tape because I was trying to save time, but I think the water's gonna sneak in. So I think we need to cover with duct tape. So I'm gonna start with that. And the cool thing is I actually already have some pieces cut. All right, so now I believe that I don't have any holes where the duct tape, where the water can sneak in. So I want to go back to my original design that is kind of struggling with duct tape now because it's not sticking as easily. And I want to think about, we still want those attached, but do you think maybe we don't need them as far? Maybe we could cut them down so it's not as big. So I'm going to cut some of this. Okay. I really want them to be the same size. All right, so now I still want this to come from the cup, and then I want this to be my paddle. So let's get some more duct tape. And before I start that, I'm gonna dry off my cup because we already know that if it's wet, the duct tape's not gonna stick to the cup. So I wanna make sure it's really dry. All right, grab some more duct tape. Okay. I'm gonna go in the middle this time. All right, so now let's connect the paddle to the skewers. But I want to go back to the problem that we had, that these skewers were being pushed in too far here. I have an idea that actually might help with that. So I'm gonna push this a little bit out this way, and I'm gonna use a rubber band on this side to hold. Okay, so I need those to be a little bit longer this way. That's all right. This might not work, but if it doesn't work, hey, it was worth a try. So I'm gonna put rubber bands on this side to hold them this way so that when I actually do put rubber bands over here, it has an energy resistance on this side. Let's see if that'll actually work. And then we're gonna attach this here. Okay, I'm gonna twist that around. I'm really hoping that this goes in the water. I'm wondering if I'm gonna have to make that a little bit lower. Okay, now I'm gonna twist it up pretty tight so that the potential energy will be enough to let it go. So let's test it out and see what happens. All right, oh, actually I'm gonna start back here. Okay. Oh, it's almost making it go this way. So what if I start at the front? You know what? I think I was twisting it the wrong way. We need to twist it the opposite way to make it move forward. I kept making it go backwards. So let's try again. Okay. Okay, so when we did it the opposite way, it pushed it forward, but it pulled so much on the boat. So how can we keep the boat weighted down in the water? Right, use our washers. Let's add 2 just to see what happens, because we have 4, so maybe 2 will be enough. All right, I have to think about which way I want it to go. I want it to be pushed forward, so I want to wind it up backwards. All right, that was my problem, or that was our problem the first time. We were winding it the opposite way and it went backwards. All right, let's try one more time. Hopefully this has got it. Okay, so it's moving around in a circle now. Oh, so that really didn't work, but we still got the boat to float, and it was moving, so the paddle was doing its job, but instead of going straight, the boat was actually moving around in circles. So let's talk about maybe why that happened. Well, we were using the weight to hold the boat down because the first time we noticed that the boat was just flipping over. And when we put the weight inside of the cup, when you look at that, it actually is distributed unevenly. There's more weight on one side than the other because of the tiltness of the weight inside. So what could we do to solve the problem of the weight being distributed unevenly? Let me see it. I can try and push it down in there, but that's not working. I could cut the cup, but if I cut the cup, it's probably gonna make water come in, and then it's gonna sink completely. So, well, I could tape it to the side, but if I tape it to the side, it's still gonna be too heavy there. what if I taped it to the bottom? So then if I taped it to the bottom, it would have the same amount of weight. Let's try that and see if it works. Okay, so now I have taped this weight on the bottom, and I really tried to make sure that it was evenly distributed so that it wouldn't tilt from one way or to the other. So let's see what happens now. So I have my paddle still, and I still have the rubber band on this side to kind of counteract the energy that's going to be pulling these two together. So let me put that on. And then we had that one problem where it was going the wrong way. So I need to make sure I wind the paddle up correctly. So I want to wind it the opposite way I want it to move. So I'm going to wind it back. Okay, I'm going to wind it as much as I can. All right. Fingers crossed. Let's see if it works. Easier if I use my right hand for that. Okay, kind of worked, went to the left. I'm gonna try it again. Okay, let's see if it works. Wind it up. All right, it's moving. It was moving straight. Now it did start curving, but it wasn't moving in a circle. So, is it perfect yet? Absolutely not. As engineers, would we redesign it and add it to make it even better? Of course. But I think we've got an excellent boat here that can obviously move on its own. Wow, whew. That was a lot of work today, but thanks for sticking with me. All right, it's moving. It was moving straight. Now it did start curving, but it wasn't moving in a circle. So, is it perfect yet? Absolutely not. As engineers, would we redesign it and add it to make it even better? Of course. I think we've got an excellent boat here that can obviously move on its own. Welcome back. Today we're going to talk about an engineering that affects everyone, because this type of engineering really and how it works and the process of getting something completed and but what's something that you probably have to do almost every day? Dishes. I know my mom used to make me do that too. And then I would dry them and put them away, and then I would dry my hands at the very a lot of my steps. I play more, which is what I really wanted to do.
So basically, industrial engineering is developing and improving upon systems, making them faster. But if you think about with industry, they also have to make them more cost effective, or they're cost competitive. But as an industrial engineer, you really are. So you're not necessarily inventing new things, but you're inventing new things. It's important because that's why things can get to you as cheaply as they can. Wow, industrial engineers have really made a difference in our world.
Have you ever wondered why plugs have 2 prongs? Some of them have 3, but most of them have 2 prongs. I wonder why that is. Today we're going to investigate some electricity. All electrical devices in your home are powered with electrical energy, either by plugging them into the wall or powered by a battery. But what is it that makes these electrical products or electrical devices work? They're all parts of circuits. Today we're going to look at circuits and what makes a complete working circuit. How can we make them, and what happens if there's something missing from the circuit? So let's take a closer look at the parts of the circuit. To make a complete circuit, you need a power source. I'm going to be using a battery. The battery is going to be inside this battery holder. You don't have to have a battery holder. It's just easier when working with circuits. Now, one thing I want to try to do today, power something. Complete circuits have a power source and something it's going to power. I have a light bulb and I have a buzzer. How can I get the light bulb? One side of the light bulb, and then I'm going to continue the circuit with another wire, and I will complete the circuit by connecting the wire back to the battery or the power source. When I'm going to put the wire of the light bulb. Then I'm going to connect the other side of the light bulb to the negative side. There's my first complete circuit. Let's try something. Close your eyes for a second. No, do it. Close your eyes. Okay, open your eyes. What? Well, the light bulb's not working, so something has to be missing. the light bulb or the buzzer. Let's try this one with the buzzer. All right, so I have my power source. Let's go ahead and draw that in our journal. Make sure you label the
Powered by a
positive
battery.
and the negative side.
what
and we're
is
going to
it
connect
that
the
makes
wire
these
from one
electrical
end of the
products
battery
or
to
electrical
one side
devices
of the buzzer.
work?
Now I'm going to connect
all
this
parts
to
of
my
circuits.
switch. Okay,
Today
now I'm
we're gonna
connecting
look
this
at
wire
circuits
all
and
the way
what
back to my
makes
power
a
source.
complete
Okay,
working
I don't
circuit.
hear the
How
buzzer.
can we make them?
That's because
and what
my
happens
switch
if
is
there's
open.
something missing?
Let's go ahead and close
from
the
circuit?
switch and see if
So
we
let's
can close the circuit.
parts of the circuit.
Turns off.
You need a power
Close.
source.
It turns
I'm going to
on.
be using a battery.
Okay, let's do one more.
The
Close
battery
your eyes
is going
and
to
let's see
be
if you can
inside
figure
this
out the
battery
problem.
holder. You don't
No,
have to have a
really
battery
close 'em.
holder. It's just easier when working with circuits. Now, one thing
Okay,
I want
open
to
your
try
eyes.
to do today, power something.
All right. What is missing
Have a power
from
source
this circuit?
and something it's going
Well,
to power. I have
have
a
the
light bulb
power source.
and I have a buzzer.
I have the switch
Get
closed.
the light.
Why isn't it working? Oh, there's nothing here to use
One
the
side
power.
of the light bulb.
I need a light
and then
bulb to produce
I'm going
energy.
to continue the circuit
So
with
I could
another
add a
wire,
light bulb or I could
and I
add
will
my buzzer
complete
back
the
in.
circuit by connecting the wire back to the battery or the power
All
source.
right, let's add that to our circuit. So from the battery, we're going to add our wire,
I'm
which
going
was
to put the
connected
wire.
buzzer has two wires coming out
Then
from it.
I'm going to connect the
One
other side
wire
of the
is
light
connected
bulb
to the
to the
battery.
negative.
Other wire is connected to
There's my
the
first
switch.
complete.
Connect the switch
No, do it. Close your
back
eyes.
to the battery or the power source.
Okay, open your eyes.
There's a complete. We're going to add our
Wire.
for the buzzer
I'm
to
gonna
work.
put the
Connect
wire.
it, has to close. Buzzer has two wires coming out
Then
from it.
I'm going
Need
to connect
be
the
one
other
wire
side of the
is
light
connected
bulb
to the battery.
negative.
The other wire is missing.
There's my
The
first
circuit
complete.
won't work. Back to the plug. Connect the switch.
No, do it. Close your eyes.
Like
To
the
the
wires
battery
in
or
our
the
circuit,
power
we needed
source.
at
Okay,
least
open your
two.
eyes.
There's a complete
Wire.
the buzzer
I'm going to
to
put the
connect
wire. The other side of the light bulb to the negative. There's my first complete. Switch. Do it. Close your eyes.
Like
To
the
the
wires in
battery
our
or the
circuit.
power
We needed
source.
at
Okay,
least
open your eyes.
There's a complete
Wire. I'm going to put the wire. The other side of the light bulb to the negative. There's my first complete. Switch. Do it. Close your eyes. Complete. Wire. I'm going to Do it. Close your eyes. I'm going to Do it. Close your eyes. I'm going to Do it. Close your eyes. I'm
Any electrical device in your house is powered by electricity. These colored lights, I plug into the wall and they light up beautiful colors that I can decorate my house with. But every time I want to turn them off, I have to unplug them from the wall. So one thing that engineers do that when they're designing things that have electricity in them is they use switches. Now there are switches in lots of electrical devices. Like this lamp over here has a switch that turns it on and off. I don't have to unplug it from the wall. My cell phone has a switch so that I can power it on and off. This timer has a switch so you can turn it on and off. Even your walls have switches so you can turn your lights on and off. Switches are helpful in everyday life so that you can stop and start electricity. So let's go ahead and do some investigations with parallel and series circuits using switches. We're going to start with a series circuit, and we're going to make sure that it is in one path. So I'm going to take my switch. So this isn't what my switches look like in my house, but they act in the same way. If you think about the switch on your wall, when you flip it up or you flip it down, maybe you push it in. That's very much the same action. Opening and closing that circuit so that it's open. Electricity cannot flow and close where it can. Okay, let's go ahead and investigate in a series circuit. So let's go ahead and add a light bulb to our series circuit. So this is just going to be one path, and we're going to add a switch. Now currently, the switch is closed. It's touching. I'm going to open the switch, and let's see what happens. But the light bulb is not on because the switch is open. If my lights are off, the switch is open, and when I close the switch, the light comes on. Open, closed, off, on. That's pretty neat. But what happens if we create a parallel circuit? What happens with the switches if we turn them on and off? I'm going to open this circuit while we create it. So here, instead of this path, we're going to create a second path. If there are two or more paths in the circuit, it's a parallel circuit. So let's go ahead and make a second path. And I always like, when I'm doing circuits, thinking about a car or a little toy or even your finger tracing the path of the circuit can really, really be helpful when you're trying to solve problems, if your circuit's not working, or if you're unsure if it's a series or a parallel circuit. And let's double check and make sure that this is a parallel circuit. So in a parallel circuit, start here from our power source, go through this light bulb, or go by this light bulb. Very cool. So here's our parallel circuit. Now let's predict first. What's going to happen if I close this switch? Wow, look what happened. Only this light bulb lit up. That's interesting. I thought in a parallel circuit, both light bulbs would stay on. The electricity travels this direction, lights the bulb. That's one path. Let's check our second path. I start at the power source. I'm going to go in my other direction. What do this is like the train tracks. Open like this, the current cannot travel through the wires. This we need to switch. So he can continue on his. Let's do one more test. We've opened. It will happen if we open this switch. Think about that now. All right. Both. Why do you think that? The light bulb following the wire. switch had to be down for both of my light bulbs to turn on. Let's close the switch and see if we fix our problem. Yay, we did it! The best thing that you can do when you're solving problems with circuits is follow the path. Check to make sure that the switches are closed, everything is connected. If there's any block in the road, anything that's open, pass, remember, next time you turn out the lights, remember that you're opening that circuit so that electricity doesn't flow. It's really helpful for the environment too, so make sure that you only turn your lights on and close that switch when you need them. Oh, yes, this is going to be perfect. Oh, hey, maybe you can help me. So office in my house that I like to do all of my work. In there, and then they start bothering me, like climbing under my desk and all that kinds of things. So I was thinking while I was working, maybe scare them a little, or tell them, hey, mommy's working, don't come in here. So I thought I could use knowledge of circuits to create some sort of device that can turn on when So let's look at all that we know about circuits and try to help me come up with a plan for this device. All right, what kind of things do I know about circuits? What can be in a circuit? We have wires, like a battery. It's not safe to stick things in the outlet, so let's stick to batteries. We can use buzzers, and we can use switches. How can I create a circuit? What kind of circuits are there? Well, I know there are series circuits that have one path, and there are parallel circuits that have two paths. So which one would be best for my plan? Well, let's see. What do I want? I feel like with my kids, the buzzer would really get their attention, but maybe the light bulb wouldn't be so scary. Let's try one of each. What if I started with the battery? Here's my positive side and here's my negative side. And I could connect a wire that will be on a switch. And then when the door is opened, the switch will close. When the switch closes, what do I want it to do? Maybe if the switch closes, it can turn on a buzzer. Let's do that. Let's turn on a buzzer. So here's my buzzer. I'm going to label it buzzer. And then it will go to a light bulb. So the light bulb and the buzzer can turn on at the same time. That will really give them a warning that they should not be in there while mommy's working. And then what else do I need? Is this a complete circuit? Let's follow the path. All the way around, up. I need to connect the last wire to the battery. Now I have a complete circuit. Okay, now that I have a plan, let's go ahead and create this circuit and see if it works. Okay, first thing I need is my battery. So here's my battery. It's gonna go into this battery holder, and I can connect this to the wall somehow. And let's look at our plan. So from the positive side of the battery, it is going to a switch. So let's get a switch, and we're connecting it with a wire. So we'll grab a wire, connecting it from one to the other. Okay, let's go back to our plan. Let's keep this open until we're ready to test it out. Now we're gonna go to our buzzer. So let's get our buzzer. And I'm gonna use this little cap to help screw it on. Okay, now let's look at the plan. From the buzzer, it will be connected to the light bulb. Okay. And then our plan says the light bulb will be connected back to the battery. And this is a series circuit. Okay, let's see if it works. It's not working. Let's look at the plan again. Okay, here's my light bulb. Then it travels to the switch and there's my problem. The switch needs to be closed. Let's test it. It's not working. Scientists always have to figure out where their problem is. I know that the circuit needs to be complete. So let's check the connections. Sometimes my buzzer doesn't get connected very well. As a scientist, I think this is kind of hard. How can I make this easier on myself? Well, I know the alligator clips can work, so I'm going to take these off and I'm going to use my alligator clips because they have a better connection. There we go. Okay. So now we had the wrong direction. I switched it and now it's working. Yay, we did it. Whew, that is loud. Remember, as a scientist, I need to continue testing these ideas. It's not always going to work the first time I try it. I make lots of mistakes. I'm human just like you. So remember, don't get frustrated. Try something else. Ask questions. Think about what you know. And I know that you can be successful at creating circuits.
Where are you going?
Take a look around you. Kaboom. I got this. I got this. Take a look around you.
Where are you going?
Kaboom. 멍게교수인가? 멍게교수인가?
Where are you going?
Kaboom. 멍게교수인가? 멍게교수인가? 멍게교. Take a look around you. 멍게교수인가? Kaboom. 멍게교수인가? I got this.
Where are you going?
Take a look around you. 멍게교수인가? 멍게교수인가?
Where are you going?
Take a look around you. I got. 멍게교수인가? I got this. Take a look around. Boom. Take a look around you.
Where are you going?
Kaboom. I got this. I got this. 멍게교수. Kaboom. 멍게교수인가?
I'm very angry!
Where are you going?
Kaboom. I got this. I got this. Kaboom. I got this. Take a look around you.
Where are you going?
Take a look around. Kaboom. 멍게교수인가? 멍게교.
I'm very angry!
Where are you going?
Kaboom. 멍게교수. Take a look around you. Take a look around you.
Where are you going?
I got this. Kaboom. I got this. 멍게교수. 멍게.
Where are you going?
Kaboom. I got this. 멍게교수인가?
It looks like you were able to hook this circuit up and turn on 3 buzzers. The problem is, right now, the switch is in the off position, but the buzzers are running. So that means that when there's not a storm and the alarm is turned off, the buzzers are going to run and the alarm's going off. We want it so that we can have it in the off position and the buzzers turn off. We can have it in the on position and the buzzers turn on. So you need to rewire this circuit so that it goes through the switch properly. Now let's remember, with a switch, there's an off position, which on this one is this 0, and there's an on position, which is this 1. What happens is, if it's in the off position, electricity cannot flow from one side to the other. It stops, and so the electricity can't continue on to the circuit. If it's in the on position, the electricity can flow from one side to the other. So what you need is for your circuit to go through the switch before going on to the rest of the buzzers so that you can control that with this switch. So take another look at this problem. I know you can do it. Good luck.
Do you think we can use this nail to pick up some paper clips? Let's try it. Well, if your hypothesis was no, you are completely correct. So let's do another test. What if we take this coil of wire? We can see the wire's been wound round and round and round this nail before the lesson. And if we place this coil of wire around the nail, now do you think we'd be able to pick up the paper clips? Let's try it. Nope. Okay, one more test. What if we attach this wire to a battery? Then do you think we'd be able to pick up the paper clips? Whoa, magic. So what we've made here is a simple electromagnet, and it behaves like a magnet, but only when there's electricity running through it. If we undo the electrical current, then the paper clips fall. Well, they mostly fall. What's going on here? Well, inside this nail, the magnetic fields of the magnets have lined up because we had that electricity running through it. Well, what would happen if we scrambled their alignments? So we'll knock it on the table a few times. Now let's see. Nope, can't pick them up anymore. So isn't that cool? You can actually magnetize a nail. Look at this electromagnet. We can see that this one has a lot more coils of wire on it. So it should be a lot stronger. Let's attach it to a AA battery. Ooh, we almost got more. All right, that's quite a few. Drop it over here. Now another way that we can make electromagnets even stronger is if we hook it up to a stronger battery. Because if we have more current flowing through the wire, then we get a stronger electromagnet. So let's try that. We'll hook it up to a 9 volt. See if we can pick up even more. Whew. So let's compare our piles. First is the small electromagnet that had less coils. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 paper clips. Now let's look at the bigger one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we got a little bit more. And the reason I think we didn't get even more than that is because there is some resistance from these wires. So there'll be more resistance than if we just had the battery just held on like we did with our first electromagnet. Okay, let's see how many paper clips we got with the stronger battery. 1, 2, 3, 4, 5, 6, 7.
Study the painting. What kind of form do you see?